Welcome to the part 3 of the lecture series of numerical integration. In the previous lecture, we discussed the algorithm as well as the different formulas for numerical integration, and I pointed out that the examples are easy, but the data in which it is given to you, maybe sometimes it is difficult to understand. So to overcome that problem, let us look at some different examples where you will come to know how the examples will be given to you and how do you understand the data given in each of the examples. Okay, let us start with the first example. So you can see in the first example, the integral is given as 1 to 7 y dx, and you are supposed to solve it using the 3 rules. Okay. So as I told you earlier during the explanation of the algorithm, many of the times if you are lucky, then the data will be given in this form. Okay. So you can see that x values are given and corresponding y values are also given. So what are these values? So this is x0, this is x1, this is x2, x3, x4, x5 and x6. Okay. So number of intervals 1 to 2, that is first, 2 to 3, 3 to 4, 4 to 5, 5 to 6 and 6 to 7. Okay, so number of intervals is 6, and the corresponding y values can be denoted as this is y0, this is y1, this is y2, y3, y4, y5 and y6. So here the example is very easy. All values are given, you have all the y values, so you just write down the formulas given which you already know, substitute these values and simplify and get your answer. Okay, now let us go to the next example. Okay, now in this example you can see that this kind of table is not given, but what is given? The integral is given, the limits are given 0 to pi sin x by trapezoidal rule. And it is mentioned as 10 subintervals. So what is this 10 subintervals? So here 10 is n. Okay, so n is the number of intervals. So n is given to be equal to 10. So since you know n, since you know this is a, since you know this is b, we can calculate h. What is h? H is the length of the interval. So h is b minus a upon n. Using this formula you can get h. Using h, you can find out the different values of x. How do you find the different values of x? Initial value of x is 0. The next value of x is going to be 0 plus h, whatever h you calculate. Next value of, and that is going to be denoted as x1. So once you have x1, x2 will be x1 plus h. x3 will be x2 plus h and so on. So once you have all the x values like this, you can calculate the corresponding y values using the function. What is the function? Sine. Here the important thing to remember is that since the limits are given in radians, the value which you find for y using the formula sin x should be in radians. Okay, let us go to the next example. Okay, let us see what is given here. N is not mentioned, nothing is mentioned, only the formulas are mentioned. And the limits are given. So a is 0, b is pi by 2, the function is given. That means n is not mentioned, even h is also not mentioned. So what we do is, we take here, we assume n to be equal to 6. Using that and using the values of a and b, we can calculate h. Once we calculate h, we can calculate all the x values between 0 to pi by 2 using the increment formula, that is xi plus 1 equal to xi plus h. First, once we find x values like this, x values, we can find the corresponding y values, denote them by y0, y1, etc. Write down the appropriate formula, substitute the y values and simplify and get your answer. Okay. Now the next example. Okay, what is the next example? Again, limits are given, function is given, function is 1 upon x cube plus x plus 1. Here you are going to use Simpson's 1/3 rule. What is given here? Choose the step size as 0.25. Now what do you mean by step size? Step size is also nothing but h. H is the difference of the interval or length of the interval. also called as step size. So here h is given, here a and b is given, function is given. Using h, you can use the formula xi plus 1 equal to xi plus h. Using this formula, you will calculate x values in this way, like this. Find the corresponding y values using this formula 1 upon this expression of x. So once you get x and y values, you denote y values as x y naught to yn in a similar way. Again, write down the appropriate Simpson's quantity formula, substitute and simplify. Last type. Okay, this is our special case of the example. Now let us read this example. The velocity v of the particle at the distance s from a point in its, this is an application, okay, in its linear path is given by the following table. So s is given, okay, s is the distance, v is the velocity given. Find the time taken by the particle to traverse the distance of 20 meters. So you are supposed to find the time. What is given to us? The distance is given and the velocity is given, and you are supposed to calculate the time and not. So that means this is a tricky table. So s is nothing but your x. So x values are given, but this is not y. Y is going to be, y is going to be. So you need to remember the formula for the velocity, distance and time formula. Using that formula, we can take that as your function. So function is going to be time, okay, not velocity. So write down the formula for time. Find out the values of time for the corresponding given values of the distance and velocity. Okay, so you get new one more row here for t. You get the values of t, and those values of t are going to be these values, y values. Okay, so those values will be noted as y naught, y1, etc. up to yn. Then use the appropriate formula, substitute and simplify. We'll stop here for this, and in the next lecture we will be solving examples, different examples, using looking at different types of examples, different type of data. Okay, thank you for today. Thanks a lot. If you have any queries or any doubts, please let me know. Go to my webpage, go to my Instagram or FB account and send me a message. Thank you. Thanks a lot.